All right, so this video is on cones, and a cone is a solid whose one base is a circle. And there's an example of a cone. See, it's got a base that's a circle. Looks like an ice cream cone. And we're going to be calculating the same things for this solid as we have for our previous solids: base area, lateral area, total area, and volume. And notice that the dimensions of a cone, which I've got shown here, the radius of the cone, the height of the cone, and the slant height, similar to the radius, the height, and the slant height that we've seen in other solids. And if you break this orange triangle here out by itself, and you can see you've got a right triangle here where this leg is the radius, this leg is the height of the cone, and the hypotenuse is the slant height. And so this triangle, as you can probably imagine, is going to be very helpful for calculating certain dimensions of the cone that we might need to calculate one of our values, base area or lateral area or volume. And if we're not given that value, we're going to use this right triangle to calculate it. So the first thing we're going to look at is base area. And the base area of a cone, since our base is a circle, the base area is just the area of a circle, which is pi r squared. This first example, it says find the base area of the following cones. And now I haven't actually drawn the picture of the cones that you have in your notes. I've just written down from the picture the radius of each of those three cones, since the radius is all I need to calculate my base area. So for example number 1, my radius is 3 centimeters. So my base area is just pi times radius squared, 9 pi square centimeters. Example B, I'm not actually given the radius, I'm given the diameter of my base. My diameter is 12 centimeters. Well, if my diameter is 12, my radius must be 6. So again, base area is pi times radius squared. So that's 36 pi square centimeters. And my last one, I have a radius of 4 feet. So my base area is pi times radius squared, 16 pi square feet. Now the lateral area of a cone is just the area of the sides, if you want to think of it as the sides of a cone. It's just the curved surface part of the cone. And to find the lateral area of a cone, it's similar to the lateral area of a cylinder. If you remember when we talked about the lateral area of a cylinder, we had a little soup can, and I unrolled the label off the soup can, and we found that the lateral area of a cylinder can be found by 2 pi r times the height of the cylinder. Well, the lateral area of a cone is similar to this, except it's not actually 2 pi r times the height, it's 2 pi r times the slant height, and it's 1/2 of that value. So it's similar to 2 pi r times the height for a cylinder. It's 1/2 2 pi r times the slant height. Now if I multiply 1/2 times 2 pi r, these values here are going to cancel, and my final formula is just going to be pi times r times the slant height. So let's take a look at some examples calculating the lateral area of a cone using that formula. So example number 2, I have a cone here. My radius is 3 centimeters. My slant height is 5 centimeters. I want to calculate the lateral area. Well, the lateral area of the cone is just pi r times slant height. I've got my value for r, my radius. I've got my value for slant height. So I just plug those in. Pi times 3 times 5, and that gives me 15 pi. See, this is area, so I've got square units. I want to calculate the lateral area for example 2b, and let's see again, I know my radius is going to be 6, half of my diameter. I've got my slant height here, so lateral area is pi times r times slant height. So pi, radius is 6, slant height is 10, and that gives me 60 pi, and again it's square centimeters. Now, example 2c, I've got my radius. I need that to calculate my lateral area, but I don't have a value for my slant height, which means I'm going to have to figure out what my slant height is. In order to do that, I'm going to break out this right triangle. And let's see, this leg of my right triangle is 4 feet. I'm looking for my slant height, so I don't know what that is. And let's see, well, I don't know that height either. Oh, but I do know this angle here, which is 60 degrees. Now that's going to be helpful because I know this angle is 60 degrees. I know this angle is 90 degrees. That means this remaining angle must be 30 degrees. Well, I've got a 30, 60, 90 triangle, which means that I know the ratio of the sides of this triangle are 1 to 2 to radical 3, which means I immediately know my slant height must be 2 times the length of my shortest side. 2 times 4 is 8. Now I have my radius, I have my slant height, and I can plug that into my formula. So my lateral area is pi times radius times slant height, which is 32 pi, let's see, now I'm in feet, so that's square feet. Now, once again, as before, total area is just the base area plus the lateral area, or BA plus LA. And so for example number 3, since we've already calculated the base area and the lateral area, I'm going to ask you to do example number 3 on your own. And we're going to go on and talk about the volume of a cone. Now, the volume of a cone, it turns out, is very similar. In fact, it's identical. The formula is identical to the volume of a pyramid, which is 1/3 times the area of the base times the height. Now, in the case of a pyramid, our base was always some type of regular polygon. In this case, the area of our base is always a circle, so we're going to have 1/3 times the area of a circle times the height of our cone. So let's take a look at example number 4 here. We want to calculate the volume of this cone. I've got my formula, 1/3 area of the base times height. I also already know the area of my base because I calculated it back in a previous example. So all I need is, I'll just write this here, 1/3 base times height. All I need is the height of my cone. Well, I'm not given the height, so I'm going to have to break out this triangle here, my right triangle, and see if I can figure out what it is. This is H, that's what I'm looking for. I've got this, my radius, which is that leg of my triangle, that's 3 centimeters. My slant height is 5. So I've got a right triangle, I've got 2 of my sides, I can use the Pythagorean theorem, and I also note that this is a right triangle with one leg 3, the hypotenuse is 5, therefore H is going to be equal to 4. And you can also use the Pythagorean theorem to check that if you want. That would be 3 squared plus H squared equals 5 squared. And if you do that arithmetic, you're going to get H equals 4. So now I know the value of my height of my cone. I know the area of my base because I calculated the base area back in example 1. So I can calculate the volume. 1/3. My base area was 9 pi. My height is 4. And that gives me 12 pi. And this is volume. So I've got cubic centimeters. Example 1b. Again, I know the value of my radius, it's half of the value of my diameter, so this is going to be 6 centimeters. Once again, I don't know the value of my height. Well, I break out my right triangle here. This is 6, this is 10. I'm looking for this value here, the height. So 6 squared plus h squared equals 10 squared. That's 36 plus h squared is 100. H squared is 100 minus 36, which is 64. So h is 8. Now I know my height. I know the area of my base because I calculated it back in example number 1, so I can calculate my volume, 1/3 times area of my base. The area of my base was 36 pi, times my height, which is 8, and that gives me 96 pi, and again I'm in centimeters, so centimeters cubed. All right, now we have one more example to do for this one, example 4C, calculate the volume of another cone, and I'm going to leave you to do that one. Again, you've got the value of your height that you don't know, so you're going to have to calculate the value of your height before you can calculate your volume. And we'll take a look at that one tomorrow in class.